Today, I'm working on this idea that I think is pretty fascinating. It's working with a few other guys over on makerforums.info. Please come over and join us if you want to be in on the conversation. So the idea is we're going to try to build an infinite Z printer. And obviously with an infinite Z printer, full disclosure, the goal is not to get infinite Z. It's just to get a Z that's not limited by the motion components of the printer. And so to get that, obviously you can't have rails in the Z or something like this. Otherwise, you're limited to their length. So came up with this idea that you can use something in the print itself to help raise you up. There's a few ideas we came up with. One idea that I'm kind of playing with a lot right now is the idea of just having these pillars right around the part, and then you can just set the printer, and they can be supported by those. And the printer, it can print those pillars itself. And the problem is how do you print on these pillars whenever you're supporting the printer by them? So to answer that is the reason there's 6 also is that you can support on 3 and retract 3, and then you can do a swoopity-doo and you can print on the other 3, and just keep on flopping back and forth. So in a real scenario, the target print, we could be printing at like 0.1 layer heights, 0.1 millimeter, and the towers are going to be printing at 0.2 because you only get to them every other layer. And so these tabs would come down, and they would, whenever they were sitting on a tower, the nozzle would be just the perfect layer height above what's already been printed, and you just switch back and forth, and you do this, interesting ratchet motion. I printed. I just wanted to kind of get a physical feeling for it, so I printed one of these tabs. Obviously, the real machine might have a completely different looking tab, and there would probably be, some kind of foot that's at the end of this that has some micro adjustment. And but it's really quite simple. You just turn it, and then it goes down. And once you get to the bottom, it locks into place. It's pretty rock solid. There's no reason we couldn't have a belt pulley system that would be able to apply enough torque where that's kind of really locked down. And then you just turn it the other way, and it comes right back up. And once it clears that lip down there, it swings out of place. Now you'll have to rely on friction between the nut and the screw, and that's a pretty easy thing to do. This is a plastic print, so there's like plastic threads, so that's pretty easy for them to have enough friction. If we used a metal screw with metal thread with metal nuts, I'd just have 2 of them, and I'd spring them together with a certain amount of tension to make sure that this would turn with the screw for the most part, but wouldn't be too tight. And I did some tests, if it gets stuck and you kind of lock it down, it still likes to slide out and then into place. It's really hard to get this not to work as advertised. And one thing that is going to be a little bit, challenging is I can't run this like a normal Z. Whenever I go from one Z layer to the other, I'm gonna have to coordinate these 2 steppers, and I can't have all these slave together. Well, I could have it where I have 3 of these that are like this and 3 of them that are mirrored. So whenever I'm turning all these pulleys the same direction, half of them are raising and half of them are lowering. And the problem with having them all on the same stepper is, they're going to meet in the middle somewhere, so the nozzle will have to dip a little bit before it raises back up. I'd rather the motion not dip and then come back up, so I'd probably throw 2 steppers on it. So I would bring all the tabs and deploy them down and then retract the other set. So there you go. So this is a top-down view of what it would look like with the tabs. Here is what it would look like roughly isometric with these towers without the printer on top. You'll have to imagine what that would look like. I'm not at all tied to this idea. We considered quite a few other ideas, and we're still considering ideas. We could print one big screw that the print could kind of rotate around. You could print rack and pinions on the side of supports. There's any number of things. What I really like about this one that none of the other ones have yet is this one. All you have to do is adjust all the tabs to meet the table at the beginning of the print, and you don't have to worry about perfect registration in the X and Y on all those tabs. A lot of the other approaches that we were thinking about requires a lot of fiddly, calibration. This one, I think, you could take a normal XY stage and throw these tabs on it, and you could probably get off the ground without doing anything too fancy. Will we get shift? Will we get, twist? Will the level change? I think we can have solutions for some of these things, but I don't know how big of a problem it is and how far you have to get off the ground before you start having these problems. I assume you could probably get 100 millimeters before you notice many artifacts, but who knows? Maybe it's maybe you can get a meter before it's a problem. Maybe you can only get 10 millimeters. So I'm a big fan of trying something that's stupid, that's simple and easy to try, and then maybe we could try something more complicated in the future. So yeah, I'm kind of really satisfied with this tab where it swings in and out. Nothing too fancy here. Let me know what you think in the comments, or go over to forums.makerforum.info. I'll put the link in the doobly-doo, and maybe some of you guys have some awesome ideas that are even better than this. Not that this is great. We'll see. Maybe it'll fail miserably, and maybe it will be the best idea ever. Well, thanks for watching.